course itself, being conducted online, was cited as a live example of the effectiveness of technology-enabled teaching. Online and blended learning platforms such as NPTEL, Coursera, Udemy, and free certification courses from Harvard were introduced as valuable resources for continuous professional development. This session highlighted how technology supports flexible, accessible, and learner-centered education. The principles of NEP 2020 were discussed in relation to pedagogy. Coming to Module 6, Activity, Classroom Practices, and Conclusion. This module included activities and concluding reflections. It brought together all the ideas discussed earlier and encouraged participants to reflect on their own teaching practices. Topics such as lesson planning, types of learners, intrinsic and extrinsic motivation, micro-teaching, classroom management, ethics in teaching, research-informed teaching, teacher competency frameworks, and student feedback mechanisms all were discussed. Challenges in higher education, such as large class size, diverse learner needs, and technological adaptation were identified. Strategies to overcome these challenges included blended learning, active learning strategies, and continuous professional development. Finally, the session concluded with a discussion on future trends in education. The growing role of artificial intelligence, personalized learning systems, data-driven education, and lifelong learning were identified as emerging directions. Teachers were encouraged to remain adaptable, technologically aware, and reflective to remain effective in the educational landscape. The session concluded with reflective questions that encouraged participants to introspect on their own teaching practices, particularly the question, what will you change in your teaching practice? We had a questioning round conducted at the end of the session where Dr. Punge presented 4 MCQ type questions to all participants. Another striking aspect of this session was the emotional depth with which Dr. Punge spoke about teaching. At the beginning of the program, he had modestly mentioned that his English might not be very strong, yet by the end of the session, one of the participants from the English discipline appreciated his clarity and confidence. This moment itself reflected an important message. Sincerity, clarity of thought, and commitment matter more than linguistic perfection. It also highlighted the humility and openness that are essential qualities of a good teacher. In conclusion, the 4th session emphasized that effective teaching is rooted in empathy, reflection, inclusivity, and continuous learning. It strengthened our understanding that teaching is a responsibility of nurturing minds and building futures. I sincerely express my heartfelt gratitude to the whole team of UGC MMTTC, Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar, for organizing such a meaningful and academically enriching refresher course. Thank you.
Thank you, ma'am. So today's morning resource person has been joined the Zoom meeting. So on behalf of UGC MMTTC, Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar, I welcome Anita ma'am. I request to roll number 83, please introduce Anita ma'am. Yes, so first of all, 83, you can unmute themselves.
Okay, thank you, sir. Shall I start, sir?
Yes, sir.
UGC Malviya Mission Teachers Training Center, Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar, online refresher course in use of AI and ICT for teaching, learning, and research in higher education. Please join me, all the participants, welcoming the incredible Dr. Anita Christaline John. I would like to introduce the today's multidimensional resource person with a lot of charm, talent, experience, and knowledge. Dr. Anita Christaline J. She is working as Associate Professor in Neuroinformatic Research Center in VIT, that is Vellore Institute of Technology, Chennai. Anita Christaline John completed Bachelor of Engineering degree in Electronics and Telecommunication Engineering in 1996 from Bharatidasan University, Tiruchirappalli, Tamil Nadu. She is recipient of All India Exam Gate score during 2003 and secured high percentile. She received her Master of Engineering degree with Gate Scholarship in Applied Electronics in the year of 2006 from Anna University. She completed her PhD degree in computational intelligence from SRM Institute of Science and Technology in the year of 2018. She is currently working as Research Associate Professor in Neuroinformatics Research Center in VIT Chennai campus. She is a member in ISTE and ISCA. Her area of interest is biomedical imaging, neuroscience, bio-inspired computation, image forensics, robotics, and AI. She has published more than 35 research papers in internationally indexed Scopus and SCI Web of Science journals. She is a verified peer reviewer of SCI, SCIE Web of Science journals. She has been recognized as a reviewer in Elsevier. She has received Best Paper Award in International Conference. She has been recognized by Wiley for her top cited journal paper in computational statistics. She has published 6 patents, more than 45 papers in reputed indexed journals. So it's my honor to present Dr. Anita Christaline J. From the organizing committee. Now, I welcome once again Dr. Anita ma'am. Start your today's lecture. Thank you very much.
Thank you, sir. Thank you for your warm welcome and introduction. Once again, I thank the organizing committee for giving me this opportunity, and I welcome all the students or participants of this refresher course to this session. So my session will be related to research pedagogy or research online tools and virtual labs available. Am I audible, sir?
Yes, ma'am.
Yes, madam. Yes.
Sir, is my screen visible?
Mm-hmm.
I will start, sir. I hope my screen is visible. Ma'am, shall I start?
Yes, ma'am. We can start.
Thank you, sir.
Your voice is little low. Maybe mic was not hold properly.
Is it okay, sir?
Yes, ma'am. It's quite okay. Thank you.
Yes, ma'am.
Okay. Good morning, everyone. So I'm Dr. Anita Christaline, John Victor from VIT. I'm here to present the refresher course topic related to virtual labs and simulations. So my topic is more relevant to research area than normal teaching methodologies. So under research, if we look at, we are in requirement for more number of simulations and related technical content, which so I'm here to present the virtual labs which are available online, which is curated by many universities and Government of India. So virtual labs are like, I'm here to discuss about 4 main topics. That is virtual lab, VLab, which is curated by Ministry of Education, and Chola Central University, which is again an initiative by Government of Tamil Nadu. And these two are interlinked with Lab Exchange, which is an international online platform for virtual simulation of labs. And apart from that, we have other resources which are curatively available for research purposes, mainly related to data analysis and simulations related to engineering and core science streams. So MATLAB Online is one such tool which is available online for many researchers in different field of applications. So virtual labs, if we look at, so a virtual lab is a project actually initiated by Ministry of Education, Government of India, so under the mission of National Mission on Education through ICT. So this virtual lab is mainly designed to promote remote access to labs in various disciplines of sciences. So these virtual labs actually they are catering to the needs of undergraduate students and postgraduate students and research scholars as well. So these labs they kindle the mm, fire to explore experiments, and they are to enthuse the students to conduct the experiments on their own and to experiment on their own and learn on their own at their own pace. So it is not mandatory that they should complete within them. So self-learning and self-paced learning and experimenting is possible with these virtual labs. So these labs they provide not only experimental mechanisms virtually, but they also provide a mechanism for grading the students and as a learning management system where the students they can learn topics related. So we have documentation related to that content, and additional web resources are there, video lectures are available, animated demonstrations are available, and self-evaluation and feedback mechanism, everything is available in that online virtual lab portal itself. So these virtual labs are there to complement the physical labs which are there in the universities, or if they are lagging, they provide the mechanism for helping the students in visualize the labs. So this virtual lab initiative was done by Ministry of Education with the cooperation or with the main coordinating institute being IIT Delhi, and the contributing institutions are different IITs and Amartya University and IIIT Hyderabad and NIT Surat, College of Engineering Pune, Dayal University. So these are the major contributing universities, and the website is blab.co.in. So this project, as we saw, it is being curated. There are more than hundreds of virtual lab simulations, which are there curated in one platform by each and every core field is being handled by one particular university. And the national coordinator for this project is Ranjan Bose. And these are the universities which are related, that is the participating universities for this particular portal. And coming to the virtual lab website, so it is blab.co.in. So here it is mainly meant for uh, shaping the research experience, learning as well as research experience of students. So here we have remote experimentation capability where we can run the simulation, check the output and validate the output, and then we can give feedback related to any bug or anything present in that particular portal. So under virtual labs project, over 175 virtual labs are available as of now, and approximately 1,000, more than 1,500 web-enabled experiments are designed for remote operation and viewing capability. So the main motivation is to share the costly equipments, because many universities or many engineering colleges, they may not be able to buy all equipments required for their academic and research purposes. So sharing of costly equipments is one main motivation, and physical distances should not limit to the experimentation capability of students and researchers. And the main intention is to deliver quality lab exercises and quality lab education to all. And as we know, experimenting is more valuable than reading through text and other things. So experimentation gives a better understanding. And being in the modern world with more ICT enabled mechanisms of learning, this motivation will lead to more understanding of the concepts by the students clearly. So these are the objectives. So all exercises are provided with remote access, and it is a simulation-based lab, and the disciplines covered are science and engineering disciplines, and to some extent, maths and basic other disciplines are also covered. So it is another main objective is to arouse the curiosity of the students and make them learn on their own through remote experimentation. And it provides LMS for self-learning and through video lectures and connect, including additional web resources. Animated demonstrations are also available in these particular platforms for each and every different types of experiments. So the main objective is remote access, and it should cater the needs of UG and PG and research scholar students. And it is mainly meant for self-paced learning with, with enthused or aroused curiosity from the students' side. And it could be a learning management system that includes web resources and other animated demonstrations. So the basic idea here is the platform is supported by physical lab, which is located remotely, and through the internet, any number of remote users can get connected. So this provides a viable platform for easy learning. And the different types of virtual labs include, there are experiments related to modeling and simulation based, and experiments related to measurement based, and remotely triggered experiments are also there. All these are like inducing the notion of researchers to reality. That is, from textbook to reality, the students will gain more knowledge, and it is also scalable as it is an online platform. It is scalable for many universities and many users. So as we saw, the intended users are college students, high school students, researchers in different domains, and different engineering colleges. So all these students and research group, they get benefited from this platform of VLab. So the project, actually, if we look at into the domain, so the project covers computer science and engineering, electronics, electrical, all fields of engineering, apart from physical sciences, chemical sciences, and other science fields also, biological science, biotechnology. All these fields are uh, embedded into this online platform with virtual lab experiments. So they do not require to experiment on these particular lab exercises. We do not require any additional infrastructure from the user side or the end user. So only one computer with good broadband internet connectivity is needed. So this will enable us to learn from the resource online. So in a nutshell, if we look at this initiative by Government of India, leads to on-demand labs. So whenever a person wants to learn, or whenever a researcher wants to know about his area of interest or his domain, then on-demand labs are being provisioned by this online platform, and students can go for self-evaluation, self-paced learning, and it is integrated learning. That is, you have all related content and all related web resources, web links in one particular place related to that particular research domain. And for better understanding, animations, video tutorials are also added up, and the students or the participants, they or the users, they have the freedom to make mistakes. That is, they can learn on their own. So it is actually a complete learning management system. So this initiative, specifically, it provides simulation-based experiments to engineering colleges where these labs are not there. And where in some colleges, they may have the lab facility, but in those cases, it acts as the complementary facility for more add-on information in terms of animated videos and things. And it is a learning platform, and teacher training and skill augmentation is being done through workshops and on-site training. To get acquainted with this particular platform and to increase the usage, government has taken initiatives through nodal centers. So we look at the national wide impact. If we look at field trials have been conducted in many colleges, more than 100 colleges. 36 workshops have been conducted. So these are all data related to around more than 5 years before. So the participating institutes are more than 100 in number, and more than 50,000 students have been trained online. And coming to the quality, so because of this initiative, both the quality of the deliverable of this particular initiative is maintained, both with technical capability and with field trials. So technical capability is like midterm evaluation by subject experts, that is online, how many colleges have participated, how many users have used. So all these data are being taken then and then, and midterm evaluation is being done to evaluate the usage of this particular platform. And field trials are also being done based on feedback from students and teachers. So to teachers, mainly, they can give feedback about the usefulness, how far that particular virtual digital content was helpful in understanding that experiment and related contents being given for insight. And students' feedback is like their feedback mechanism is based on how it is usable, how easy it is to access, and how easy it is to use those virtual lab experiments and understand them. And self-evaluation, that is how far the learning component of the student has increased. So this self-evaluation is in terms of pre-test and post-test before taking up the virtual simulation. So this is a novel process initiated for virtual learning. So the feedback, whatever is taken from the students and teachers, it is given to the lab developers in that particular VLab associated with the VLab. That is all the nearly 12 to 14 universities like IITs, triple IITs, and other universities which are at the backbone in developing these simulation labs. And the experimentation, that is virtual lab experiments, they are technically evaluated by subject experts then and then, and the technical feedback is also given. So this initiative, it is again transparent throughout India. So it is a new paradigm for transparency and openness, where the admin website for all labs is open. So the list of experiments is available, and the list of equipments is available, and cost of each and every equipment at the back end is also available. And all VLab being developed, all major according to the curriculum of engineering and science in universities, all virtual lab experiments have been curated and being developed under different categories or different subject domains. So the repository actually, it has all presentations, all reports, feedback forms, field trial. So this is for checking the performance and the usage of that particular repository. And it is also being planned to link with Wikipedia so that everybody will come to know about it. And developer forums are also there to publicize the usage and availability of this particular initiative by Government of Ministry of Education, Government of India. So the ecosystem, actually, we have a set of lab developers in 4 institutes, IITs, and they have project associates and field engineers who are developing the VLab, and which is being delivered to the end user through nodal centers. So there are universities and educational colleges, engineering colleges, which act as nodal centers. And these nodal centers, they have coordinators and faculties and student members who are the end users of this particular initiative. So now coming to the success rate before and immediately after introducing in 2012, the entire success rate was turned over. That is before virtual lab in 2012, in the month of November alone, within 1 month, this is the hit, daily hits and other usage of engineering labs, teacher, how many teachers were trained, how many students are using, and how many number of lab experiments were developed. So this is the statistics showing a phenomenal growth in the usage and implementation of this virtual lab facility. So this again has a very good social impact where lab resources are shared and connecting rural and remote colleges is also possible. Only requirement is we need to have a good bandwidth. And this is again a paradigm shift in ICT based learning methodology. And it is a very good platform for exchange of knowledge and exchange of information. And overall, if we look at, there is quality improvement in education, not only in engineering domain, but in also science domain also. So this initiative is providing access to quality labs to less privileged people also. So coming to the broad areas, what are the different areas that come under the coverage of this virtual lab is electronics and communication. So these are all engineering domains: electronics and communication engineering, computer science engineering, electrical engineering,
डॉक्टर
mechanical
साहब
engineering.
क्या ऑनलाइन अवेलेबल
Hello. And these fields are related again biotechnology and biomedical engineering, civil engineering. Apart from that, physical science, chemical science, and design engineering. So these are the different domains or broad areas that are covered under this virtual lab initiative. So this virtual lab initiative, if we look at, as I told, I have shown few examples here, computer science engineering. So we have we go to the vlab.co.in, and from there, from the homepage, we can go to these broad areas. So when you click on computer science and engineering, then it leads to this particular page where we have a list of domains, a list of areas which are curated by different universities. And these domains, if we click each one, say for example, if we take under the computer science domain, computer science engineering, if we choose one particular uh, category, that is, say for example, here I have shown image processing as an example. So we have under image processing, the primary textbooks are given and what is basic information is given. So this is about introduction. And again, we will entire list of experiments. Objective is given, entire list of experiments is given under image processing. So these many image processing experiments are available. We can use one at a time, and then we can simulate and check and evaluate ourselves. So considering, say for example, I am choosing image arithmetic, the first experiment or whatever it is, then it leads to another page where we have the details of that particular experiment as shown here. Aim of the experiment, theory behind it, objective, pre-test questions, what is the procedure, what is the simulate, how to simulate, and what will be the simulation output. Assignment based on this experiment. Post-test, this is for understanding. Pre-test is for understanding the preliminary knowledge of the user, and post-test is for understanding the knowledge after the simulation. And reference and feedback, everything is given in the menu structure. So this aim is, so here for this particular experiment, whatever I have chosen, we consider image arithmetic, that is arithmetic operations such as addition, subtraction, multiplication, division. So here A and B are two different images. So we know that images are like taken in terms of matrices and then they are manipulated here. So here we can understand each and every theory behind it. So theory behind image arithmetic is given. For example, here the important requirement is input and output images should be given and size of the image. So nowadays all of us are well acquainted with using cell phone with different image manipulation, image editing, image editing operations. So we can add two images or subtract two images or find the difference between two images. Anything can be done with images. We can crop the image. We can increase the contrast. So all these are simple day-to-day activities which we come across, but we don't know the technical details behind them. So these initiatives like virtual labs, they tend to give more insight about these uh, basic image operations. So I have taken image arithmetic as an example under computer science, but similarly we have different categories. As we saw, there are more than 10 engineering categories under physical science, chemical science, and biological science also. Biological science as such, it is integrated into biomedical and biotechnology or biomedical engineering categories. So under different category or under different domain, we can have more insight and more understanding of the basic operations or the lab experiments, whatever we are doing. So the portal actually, and whatever now we are considering is the category under image processing. We are experiments. We have chosen. I have shown example of image arithmetic. So next is pre-test. So the portal again gives information, or the portal intends to collect information about the preliminary knowledge of the user before going for actual simulation and understanding of the virtual lab concept or the concept of that particular exercise. So some uh, preliminary pre-test questions are given in terms of multiple choice questions. So these MCQs can be graded and recorded immediately under that particular user login. And next, after that, procedure is given like, so these are screenshots, but in live also I'll show you online. And after procedure, this I have done for one exercise where I have gone for image addition and clipping. Okay, so primary image, we have to select the image. All are self-explanatory. The entire uh, uh, menu structure is so self-explanatory that we can choose the image as we use our apps or other applications and mobile phones. Similar to that, here we have menu structures which are self-explanatory, and we can select the image, do whatever operation, arithmetic operation we have, and we input image. Once we select the input image, it gets displayed here, and then we get the output image depending upon the selected operation. And we have other secondary image uh, parameter characteristics also we can set. And this also I have shown for another image, input image. I have shown the contrast. Previous one is for dull. So here we can see it is dull enhancement and clipping. And this one is secondary image is having the gradient. Okay, so the gradient is the two images are added with gradient. So this is how we can visualize and learn. And apart after completing the lab in simulation, we can have an assignment section is also provided where we'll be given a assignment question. We have to complete that assignment and then we can store save the results. And after the assignment, it is going for post test. That is after doing the experiment, whatever knowledge we have gained, that is being tested by post test. And then we have options for references and if for more knowledge gaining, and then we have feedback also. So this sequence I have taken for one particular virtual lab. How the pedagogy of making the student to learn virtually is being set up. That is all the in physical lab, whatever activity is being done, the entire same sequence of operation, whatever is done in physical lab is being done in the virtual lab also. Okay. So this gives more insight for the student. And if coming to the next category, like biotechnology. Example, I have taken biotechnology and biomedical engineering. So we have a set of experiments and another area, broad area of virtual labs under biotechnology and biomedical engineering. So here again, we go for, this is another category, chemical science, two engineering we have shown. Under chemical science also, we can see almost all the prominent lab exercises which are being covered in engineering colleges and then other uh, universities, arts and science universities. And physical science also is available, basics of physics lab, and all these digital anthropology lab, everywhere. So this screenshots I have shown for example. So before going to the next particular uh, next platform. So what we discussed now with VLab platform. So this VLab platform, if you look online, is my screen visible, sir? Hello?
Yes, ma'am.
Yes, okay. So this now I'm
Yes.
online. I come out of the PPT. So online, if we go for blab.co.in, this particular website is seen. So this is you have outreach and participating universities, all these things, and objectives, everything is given. So for example, we discussed about computer science and engineering, which for an example. So under this particular domain or broad area of virtual labs, we have virtual lab related to artificial intelligence, artificial neural network, automata, computational linguistics. So all these are being developed and uh, maintained online or curated online by different universities. So under these, actually, we saw the example of image processing lab. So there are many labs and link is given for related NPTEL video lectures also. So what are the labs related, what are the video lectures related to this particular domain of research under NPTEL, that is also given. So if you press this, it will lead to the Swan portal where the related topics of speech processing, soft computing, Python, all these things are given. So the example what we saw earlier, we saw image processing lab. So I'm taking image processing lab. So under image processing lab, we have the introduction being given and then objective and then list of experiments. So these are the list of experiments what we saw and target audience, everything is given. So that is not that is for we say that LMS aspect. So now going into the details of say for example image histogram. So first, what is an histogram? So that is being explained. Histogram is nothing but identifying the different pixel intensities in the image. So how this is being done, the theory behind uh, histogram, and actually technically we call it as histogram equalization, that is increasing the contrast and or reducing the contrast of an image. So this is histogram processing of an image. So when we go to simulation, so this is pre-test, some set of questions are given in form of MCQ. Next is we go for detailed procedure is given, how to select an image, how to use this particular portal simulation um, parameters. So now when you look online, so select if you keep here, select an image, I'm getting a grid. So I can choose any one particular image out of this grid. So say for example, I want to, I'll choose this. So the input image is getting done here. So full image histogram or sub-image histogram. So sub-image histogram means we have to choose this entire image will be divided into 4 quadrants and one particular portion alone will be contrast adjustment will be done. But if we give for full, then the entire image will, for over the entire image, contrast adjustment will be done. So now I've chosen full image histogram. Now I have to run. So once I run, I will get all the pixel quantity. So whatever is the image, this image we know that it is having some intensity values. So these intensity values from 0 to, this is a black and white image you can see. So the black and white image means only one intensity component will be there because color image will have 3 different components. So the initial image and process image. So here we look at, we have 0 to 255 intensity values. And after processing, if we look at, uh, actually here, if you look at, you will have the selected prominent pixel quantities. Okay, so we can see the difference between this image and this image. So this is how uh, the simulation is explicitly given to the end user so that they can change and understand. Say, for example, I want to do quadrant 2 alone, then I have to run for sub-histogram 1 and sub-histogram 2. So this is an example, whatever I have shown. So after simulation, assignment will be given. Some brain image is given, and then we are given with an assignment to do. And after assignment, we go for post-test. So this is post-test mechanism for this particular exercise. Similarly, references and feedback for each and every chariot experience. So all these are for LMS purpose. So the main intention is making this user to use the portal and gain insights into the concepts, technical concepts related to that, and then it is measured in terms of the pre-test and post-test and in the form of feedback. Okay, so this is one portal what we saw. So now coming to the home page. Home page shows all the other areas also. That is physical science. So physical science again we have these many like advanced materials, basics of science, physics lab, electric circuits, represent magnetism, heat and thermodynamics. Okay, so you be varied fields of all possible types of lab exercises are being curated and along with the related videos from NPT. Okay, so this is the area related to physical science. Similarly, we have areas related to chemical sciences also. Chemical. So each and every, whichever is the area of interest, accordingly, the researcher or the student, UGPG student, they can use their these particular exercises for more in-depth understanding of the concepts. So biomedical signal processing, bioinformatics, and bioinformatics itself, virtual lab 1, 2, 3, depending upon the level of advancement or depth of the technical content. And biomedical instrumentation lab is there, biosensor virtual lab is there, cell biology, immunology. So under biological sciences and biotechnology are put up together into this particular category of broad area of virtual labs. So this initiative is by the government of India. So this is one portal where research can be more motivated and it can be more meaningful by proper understanding. So next is coming to the next portal, that is Chola Central University portal. So this Chola Central University portal, if we look at, it is having links to virtual lab, whatever we saw now, and it is having link to lab exchange, another one in portal, which is from Harvard University. So it is a free online platform for science and engineering based education from Harvard University. So this is a platform that is the central initiative by government of Tamil Nadu. And if we look at under this particular lab exchange, if we go or we have other links also. Okay, we have other links which are taking us to open text BC. BC is nothing but the British Columbia University. So British Columbia University, they have curated online the multidisciplinary, all the virtual lab exercises and technical contents. So about so this initiative began in 2012, and British Columbia University they have taken the initiative of curating most of the technical contents of the science. So we under this initiative, they have remote labs that is curation of or they provide the link to remotely controlled laboratories based in Germany and in North America. Okay, and NANSLO, that is North American Network of Science Labs Online. And under this, they have given lab activities, 2 lab manuals with 28 lab activity plans and other things. So this particular portal, what we discussed here, that all these are given as links from this particular this central university. Okay. So under multidisciplinary, if we look at, we have many other sources or directories being linked. Four such main sources are GoLab, Merlot, Open Science Laboratory from the University of Walson Foundation, and PHET, Interactive Simulation from University of Colorado. So some of them are meant for K13 and K12 students, and others are meant for UG students as well. Okay. So while most of the exercises are designed for undergraduate, so here we can see it is mainly designed for undergraduate science programs, and some are of advanced level for school level also. So if we click all these links, it will lead to those particular virtual digital content where we have open lab facilities, simulation facilities available. So these are again meant for both in-depth understanding. So these are the lab, note labs, and other collections for science technology enabled education. So online resources for science laboratories are there. There's a consortium which provides a variety of science resources for a variety of levels, from elementary to undergraduate levels. So all these can be used for. So one example I have shown here, one screenshot of the web page from the link when we go from the Columbia. It is going to OpenText bc.ca. So here you have different, you can see the different categories or domains as under resources. So multidisciplinary is there, biology, chemistry, earth science, engineering, environmental science, maths, physics, okay? And all these are having their own set of exercises and web resources also. Say, for example, under engineering, it leads to another one, computing and data analysis environment. So it is actually based on MATLAB programming. So if for more advanced, if you go for engineering, this example I have shown for engineering, so let me for multidisciplinary and other applications also use. So when I pick that particular engineering data analysis, so computing and data analysis, when we click this particular resource, it leads us to this web page of MIT. Okay, so here it is Merlot that we have different types. Again, if you look at the web content type is also specified in some cases where some will be simulation, some will be video demonstration, some will be text references like that. Okay, so type of text will also be indicated there. So another example I have shown for maths. So under maths again we have different categories of different exercises which are spanning from elementary to undergraduate research purpose or education. So this we will see online. The second online portal is this is the Shola University portal. So here we can see online if we type as central library cutn.ac.in. In one of the slides, I have given the link for main link for all these portals also. In the starting slides that I have given. So this Shola University portal, if you look at, if we press this virtual lab, it will lead to blab.co.in. And this is again Lab Exchange, which is again another portal, which we will see in detail next after this. So what we saw here is these are the multidisciplinary. So if we press, we get multidisciplinary science resources. And if I press this biology, I get online resources of biology, chemistry, with goes on like this. Okay. So here, if we consider the biology, we get all content related to biological experiments. So here we have the content details. So for easy browsing, and then we have different experiments. And so these are the curated digital contents. So some are copyrighted, some are openly available for all, and many of them are copyrighted and common license only. So it is shareable for everyone who is having access. And we can notice that this initiative, basic and Chola University, it is under the initiative of Government of India. So they have tied, and all e-resources and contents from these platforms are easily accessible from India also. And so this is the repository, one platform for related. So this platform, if you look at, it gives more science related topics rather than engineering related topics. So this centraluniversity.cutn.ac.in can be used for more science related topics, even mathematics, earth science, everything. Mathematics also we can check. We have more content and simulation. PHET is mostly simulation for curve fitting, very good simulator for and Fourier simulation outputs are available. Everything we can simulate and check. Test. So all these are based mathematical functions. So this is the second platform what we have discussed. Now coming to the third one. As we saw, we have a link from the Central University, CUTN. There is a link for lab exchange. Okay, so this lab exchange, it provides again both simulation and online technical content. So lab exchange, the main, so here you can see labexchange.org, the website, and we can explore all the different technical contents here. So this I have shown for
पहिली गोष्ट तुम्हाला काय दिसली नाही disorder.
hello. Shall I continue, sir? So here again we can see the technical content for different. Hope I am audible. I'm audible. No problem.
Yes, yes.
So now coming to this portal where we have different varied topics, not only science engineering, we have related topics or content, simulation contents related to global health, education, economics, and learner support system, LMS based. Okay, so here in the main structure under subject area, we can see biological sciences, we have 17,000, around 17,000 technical content, and health science, physical science. So these are the simulations, number of simulations. All the number of simulations are given in here the particular broad way. And for example, if I choose genetics or the biological content, so each and every type of the content will also be specified here. So here it is a simulation. Here this again is a simulation. Electrophoresis is available as a simulation content, and transforming bacteria is also available as a simulation content. But if you say, for example, from the subject area, if I choose data science, and under that I have different categories: data visualization, computer science, machine learning, not regression, everything together. So under data science, say for example, if I choose only data visualization, so all the visualization examples will be listed here. So some may be simulation type, some may be interactive type. That is, it will take input from the end user, and then accordingly it will change the output and give. And so again, this is amplifying power in PCR. That is again and interactive sim. Interactive demo like stuff, lab, and then this again is a simulation. So simulation, we set the parameters earlier and then we run. But In interactive, in real time, it takes the input and then it varies the output. So that is the difference. So again, another example I have shown for under machine learning and AI. So clustering the Python related topics in Scilab code, and all these are also available. So this slide shows the various contents and, under machine learning and AI. Even under data science, there are many other topics. Uh, so under data science, most of the contents if we check, the content type will be text. Okay, for data science, as of now, the lab exchange, they are providing text related contents on different topics. And one other advantage of this lab exchange is they have facility in different languages. As we know, lab exchange is an initiative of Harvard University, and it is meant for international usage. And in India, we have in collaboration, it has different languages in Hindi, Marathi, Tamil, okay, and Bengali. So there are many different language versions also available. So there are different options available under language categories. So we can change the language for better understanding in our local language. So this example again shows one simulation output which I have tested for COVID-19 in infection spreading mechanism basis. How the COVID infection has been spreading. So we initial infection, the initial number of students, all these are settings which are these settings have to be made according to the guidelines of the theory content given in the simulation lab exercise, and based on that we will be able to get a visual output here. So this visual output will be shown how the infection is spreading, and the same thing will be uh, tabulated as a graph here. So we can easily copy paste the graph and easily take content from this particular simulation output for documentation purpose also. That is also possible. So this is how the simulation goes, like starting page from for the simulation, and with this actually the third type of we'll go to the lab exchange on online. So this is the lab exchange online site. Then you can see lab exchange feature virtual lab simulations. So most of the virtual lab simulations are present here. And here, once you click in, you get into the site with different subject areas. Okay, so subject area is shown here. Sources of background knowledge. We can set the background knowledge, whether we have some knowledge about that particular chosen field, or you have the knowledge, or you don't have any knowledge. And so these are other resources. And this portal, it gives curation from other simulations also, like the Concord, PHET. This is actually lab exchange. But the portal, what we are seeing now is lab exchange, and other simulation or open source simulation platforms available virtually are also contributing to the exercises available here. Okay, so these are the other sources. So what we have chosen is one, two, and again we can go for multiple sources also. Okay. So accordingly, the simulation lab exercises from those particular sources will also be pulled into this particular code. So subject area wise, if we check, we will have physics, biological science, chemistry, math, data science, process, scientific processes. So these are the different categories available. So under data science, data virtualization can be chosen, or we have different categories: modeling, programming, statistics, and probability. So all these things we can work out, or we can simulate and check according to the given parameter setting, and then we can change the parameter setting and check on our own, so that we can experiment on our own pace and learn to understand the full concept of that particular technical broad area. Okay, so this is all these are available here. couple of tabs are also given, and other things are this is maintained by Harvard University Online Lab Exchange is a platform maintained for international community. Okay, so we saw for national community, and this lab exchange is also integrated into the content central. So here from our Shola Central University, this is National Repository Virtual Labs. So if I press this, it goes to the. It is integrated with the. I get the link of virtual labs, or if I press this lab exchange, it goes to the lab exchange portal or platform of Harvard. So these are the according to content type also we can choose case study, simulation, video, narratives, okay, textbooks, images, audio for better online lecture live. And we can content source we can set, featured subjects we can choose. So these are the subjects what we specify in the previous listing, biological science. Okay. So this particular lab exchange is not only meant for engineering and science, it is also for other broad areas like health, economics, and other aspects also. So with this, this particular module 1, it comes, it concludes like we have more online resources, online virtual labs and simulations, where according to our domain of research, we can experiment and learn on our own. Okay, so this is the 3 different lab portal platforms we have discussed. So next we will be moving on to one particular online tool. Okay, one online tool which makes our experimentation more easy. So can we have a break or we continue?
Ma'am, 12:30 it's break.
Pardon, sir?
12:30 break time.
12:30. Okay, okay, 12. So now we'll move on to another online platform which is available for resources of engineering and science background. Okay, so MATLAB online. So MATLAB, as we know, MATLAB is about the short form for Matrix Laboratory. So now it is actually the 4th generation programming language. It is extensively being used for data analysis, exploration, numerical computation, and visualization mainly. So MATLAB gives very good visualization, and we can easily interpret the data whatever we are using. As I told, MATLAB is a handy tool for many researchers in the field of science and engineering. So the main characteristics of MATLAB, it involves algorithm development. There are many built-in functions within MATLAB, and modeling can be done, simulation of the model, whatever we develop, that can be done, and prototyping can also be accomplished with MATLAB. And scientific and engineering graphics or output visualization is very good. And whatever application we are developing, so we can go for GUI interfacing also. That is graphical user interface building can also be done with MATLAB. So that is one main advantage. So this graphical user interface gives us easy integration of different base functions within the particular model or program or whatever implementation we are planning for. So the major attractive features of MATLAB, if we look at MATLAB, it supports toolboxes. Actually, there are different toolboxes for different operations. As we'll see the toolboxes in detail, and there are many toolboxes. We will discuss about 15 top toolboxes which are more frequently used by research community. And nowadays, MATLAB is being used by leading students also. So it was built, actually, MATLAB it was built to realize plots from different data types. So one of the major advantages data analysis and visualization. So as my topic relates to data analysis and visualization, MATLAB is a very handy tool for many people. It helps in simulation, mathematical computing, and development of the entire application can be done in one shot. So there are other simulation experiments also, but other simulation packages also, but they are meant, each and every package is meant for one particular application. Say for example, PSpice or OrCAD, it is meant for only circuit analysis. And similarly, Cisco Packet Tracer, it is meant only for network analysis. Okay, so we have different packages for specific application. But MATLAB, being a custom built data source, we have many different toolboxes which support different applications. So that is one main advantage of MATLAB. So it allows to implement complex mathematical functions and other research related operations. So the benefits are it provides applications to scientific and engineering graphics. It can also be used for technical computation. So all the technical statistical analysis of data, everything can be done. So data analysis, visualization, and exploration. So from the analysis, what we infer. Based on that, how we can fine tune the model. So all these things can also be done with MATLAB. So it can be designed as a graphical user interface. So we can put it into app-like structure where you will have different buttons. So if you press that button, one particular code will be running at the back end. So for user, end user, it will be more easy to operate. So that is another one main advantage since MATLAB is integrated with graphical user interface. So why should we go for it? Like what are the benefits or who would be benefited from MATLAB software or online tools are teachers, researchers, even school students to some extent they nowadays they are using MATLAB related stuff for data manipulation and science engineers in technical fields and programs. So this is not it is a software which is useful for all levels of people or all levels of academic categories. Right from UG, PG, researchers and advanced research and even scientific implementations also. So different fields if we look at where the MATLAB can be used is electronics engineering, where we go for control mechanisms, circuit implementation, and in communication field, where we can go for magnetic field studies, electric field studies, antenna performance, and other things. So why MATLAB is typical uses of MATLAB is in mathematical computations, model prototyping, algorithm development, data analysis and exploration of data, that is visualization. So all these are the fields or that MATLAB could be used. Next coming to, so it is a higher level language program, but with some computational speed penalties. So we need to have some good system to run these mathematical models, and they provide very good professional looking graphs visual outputs. Okay. So MATLAB is the main thing. If we look at first, we will discuss about the environment, and then we go for online. I'll show you how to log in into MATLAB online, and then go for basic programs. Then basic operations with variables and programming visualization. So mainly we will concentrate on visualization. So first we will we'll discuss about MATLAB environment. So this is the MATLAB. Well, we can be we can work on MATLAB from online source or with the downloaded licensed version also. So online resource or what downloaded version, whatever it is, you have the main work environment like this. So here you have the current folder, which will give the folder, specific folder in which I'm working on. Next is the command window, where I can give script commands. Basic commands can be given here. But if we are working on a specific application, the code can be written as a separate .m file in editor, MATLAB editor. And this is the workspace where we can see all the variables. And this is the command history. That is the list of commands, whatever we have given here in the command window or in the program, M file, whatever we have. So first we need to understand the environment. We have all basic operations like file saving, editing, debugging. Current folder is shown here, and the current folder, what are the files in the current folder, they are shown here. So here you can see current folder is lab one under this particular root, and we can see the files in that particular current folder, command window, workspace, command list. So these are the basic components in the entire work environment of MATLAB. So in case if we want to know about any, if we require any help, then we go for the help browser. So in the command line. So in the command line means here we have to type, we can type help. Okay. So help command if we type, or product help if we type, we get this particular screen or menu structure where we can go for all the documentation related to that particular toolbox or installation procedures, basic introduction about MATLAB, what are the license versions and release notes, latest version available. All these informations are available here. And we can see Simulink. Simulink is mainly for simulation and check. So this part we will concentrate more. And apart from that, there are different toolboxes. I'll let you know a little about image processing toolbox, because image processing toolbox supports both scientific engineering applications and science related applications also. Okay. So this is the how we go for help. Okay. And say for example, product help means we can take this will come here, and command line help also will come here. In case if we want to know about a specific function, the square root is a mathematical function. So in that case, we can type help square root also. So that will give information about that particular function. So all these commands have to be typed here in the command window so that we will get the information about that particular command or function. So next is, this is the environment in which we should understand the environment. Next comes the operators. So base operators, so matrix laboratory, from the word we can understand that all the operations will be considered in the form of matrix. So whatever input, even if we are giving one variable input, that will be considered as an one by one matrix. So it is mainly applicable for all scientific and mathematical related applications. So it begins with the alphabetic character A. So it is case sensitive. All the variables are case sensitive, and there is no data typing. Okay, it can be integer or string, or this integer again it can be floating point or integer. So there is no data typing, and there are default output variable. So whatever be the input, output variable is always stored in one particular variable named AMS. Okay, and we have built-in constants I, j, infinity. So some constants are there already, built-in functions are there, built-in constants are there. So we can make use of those functionalities from in the MATLAB library. And other main functions are clear. Clear means it will remove all the variables. These are here. This is the workspace. Okay, so once we give clear, all the variables which are frequently run or which have been run till now, till then, they will be erased. So that clear will remove all the variables that are in the workspace, and it will list all the variables. What are the variables? If we want to understand a particular variable type or other things, we will type who, and who gives list of variables along with the given sizes. What is the size of that matrix and other things. Okay, apart from this, these are special characters involved in MATLAB functions. So vectors in MATLAB. So as we discussed, we represent all the inputs in the form of rows and columns. So our row 1, R2 can be 1:2. Okay, 1:5 means 5 elements will be there, and R3 is pi to pi by 3 and pi minus pi to pi, and that pi value will be divided by 3. Okay, so minus pi value to pi value, and intermediate values will be pi divided by 3. Similarly, column variable is also here. We can define columns like we defined rows, and how we create matrices. Creating a matrix here, if we look at, we have this is first row 1, 2.550, first row of elements and second row of elements. So total A is R1 and R2. Okay, it has R1 first row, second row. Other ways of creating matrices in MATLAB is by initializing with a matrix with 0. Say for example, A is a matrix, zeros of 10, 5. So it will create 10 rows, 5 columns. All the elements will be zeros. And A is a matrix with ones. We can create with ones. Okay, 10, 5. Similarly, this again is a 10 by 5 matrix with all 1 in the end. And A is again I, it will create an identity. So how we will be accessing the elements? So in the matrix structure, if we have 10 rows, 5 columns, so 1, 1 will be addressing the first row, first column element. And 1, 2 to 2, 4 means it will consider all the elements from first row to second row, and from second column to fourth column. Like that. Okay, so this is how we will be addressing the elements. And mathematical operations are basic mathematical operations, and even advanced operations are available. We will discuss only basic operations like addition and subtraction. X is a matrix, Y is a matrix, A is a sum of both the matrices. And according to matrix algebra, the matrix sizes should be uh, correct for proper addition or subtraction. Okay, so it is going to be direct addition. 1 plus 4, 5, 3 plus 5, 7, 3 plus 6, 9. Hello. Hello. Similarly, other basic operations are shown here. Element-wise operation is also possible, and dot mat operations. There are many different operations. Few basic examples I have shown. Next is coming to programming. So how we are going to enter the code, or how we are going to give the command. Okay. So that is in terms of two ways are there: script M files and function M files. This example shows one script M file. Okay, script file called file name is anim.m. Okay, so this is an animated plot showing. So all these are this example here. It shows how programming is done in a separate file. Okay, so script file is an automated series of steps. So it shares the workspace with other scripts. So all these things I'll show you online, and extend the MATLAB language. It's function files. Function files are like for a few people who have worked with coding and programming, they will understand functions can be written separately and they can be called within another main function. So M file programming always has one M file. The extension for Python, we call it as .py files. For MATLAB files, we give the extension as .m file. Okay. So we run the model. First, we always have one create a file. We give our own commands and functions, or we use the user-defined functions or built-in functions available in MATLAB. And then in the editor, we will create the model or the shell MATLAB file, and then we'll run it. Okay. One simple example I'll show you. So example model.m. Here we can notice that we are defining the input matrix P with 0, 0.1 and 30. Okay, it means that The matrix T, it is a time series which is going to run from values 0 to 30, and 0, next will be 0.01, next will be 0.02. So this is the increment value. This is the starting value and this is the end value. This is the incremental value. So in between, you will have many values, okay, with each value with an increment of 0.01. And then we are computing a model. That is, we are creating exponent relationship of this T. Actually, here it means a time series. So that is why they have given the variable T. So we are giving exponentiation of this particular time series. So time series is having an increment of 0.01, 0.01 like that. And then we are going to plot T comma Y. So this, if you plot, so this we have written it as an script, example of script file. Okay. Next is, we are writing the same thing as a function file. So function means we have to define a function y, give a function name, give all the variables, and then we have to write in terms of the function file. This is another one example showing function file. So whatever it is, from the we can get the input and output. So here we notice we have some input and output. A, B, all these things should be given here. If it is a function file, the input can be taken from the command window itself. Okay, so number is equal to input of whatever it is. Okay, so from the command window, we'll be taking the input and we will be displaying. So here, if we look at, these are the logical operators, other logical operators available, and operation. So I don't want to go into more technical details, like whoever is involved in basic level of programming in research and other things, for loop, if loop, all these things can be implemented with MATLAB. So first we have to define the number of rows, number of columns, and we are defining a matrix A, which is random, which will have a random. So this is nothing but initialization of matrix A with some random values, 10, 20. And the actual program is a simple program that sums the squares of all the elements. Okay, so it is a 10 by 20 matrix with the random values. We are going to sum up all of them. So for I equal to 1 to n, number of rows, and j equal to 1 to n, number of columns, we are going to sum all the individual square of the elemental values. Okay, a of I comma j square. So that will be, so initially sum is given 0. So 0 plus square of that particular element, everything will be calculated under one sum element. So this can be written like this with the for loop. Okay, this is one example showing for loop and program flow control with if loop. If loop, it is like if A is greater than. So this is a conditional operation. If A is some condition is greater than the other one, do this operation. Else, if A is less, take J as minus 1. Else, take J as 0. So we are going to assign 3 different values to J that compares two numbers and set J value to 1 or minus 1 or 0. Okay. If both them, if it is greater means J is 1, if it is lesser means J is minus 1, if it is equal. Otherwise, it is going to be equal. If it is equal means J is 0. Okay. So if control mechanism is also there. And other useful commands, basic useful commands are clear. All these things should be known for minimal operation and mapping. And file operations are list, directory, change directory, password, make directory, all these operation, basic file operations are also there. Next is our visualization. So coming to visualization, as we discuss, our topic is related to data analysis and visualization. We'll concentrate on different types of plots which are available. For research purpose, whenever we want to present our research outcome, which should be in the form of visual plots. Okay, so we go for linear plots or other different types of plots are there. So plot is the basic command, which is a linear plot. And whenever we give this plot command in MATLAB, it will open in the form of an figure window. Separate window will open. And in that window, we will get the plot of variable X and Y. And multiple data sets can be plotted. So it is plot X curve, Y curve. So these are variables, one variable and the other variable. And we plot, hold on, and we plot X points and Y points also. Okay. So another category is, so this is normal plot. Linear plot is a normal plot. And MATLAB has the capability of multiple plots also. And it also has mechanism for subplot also. The subplot is, we are dividing, we'll be able to present 1, 2. That is, you have two plots, one row and columns in that first figure. So you'll have 4 quadrants. In that first quadrant will be plot of time, and second quadrant will be plot of acceleration. So like that it goes on. And 2D linear plots with colors, markers, line styles can be changed also. Okay, color, different color combination within the plot. Okay, plot XY is normal plot. If we are giving this R, then we can change the color also. Okay, depending upon and marker. That is, the plot has to be marked with end points. What is the end? Say, for example, I'm having a graph like this. Okay, so what is the end point from here to here? It can be in the form of 0 or dot or X or D. And the connecting lines of the plot can be of different size. And apart from that, for better understanding of the visual plot, we can go for legends or annotating the graph with certain labels and legends. So legends we can write as points. Okay, for example, I am having a plot of XY, RO. The legend could be points, title, it could be coordinates, and X label, Y label. Okay, so this is so whatever it is, we have to go for the edit mode. Okay, plot edit mode icon should be from the plot edit mode in the figure window. We can change all these colors and other annotations in the. Okay, so now coming to the MATLAB programming. So these are visualization and other things possible. So now coming to the different toolbox and programming. And MATLAB programming language is actually user written. It has inbuilt function also. It has a vast number of inbuilt functions which we can browse and get from the help window in the MATLAB itself. And then we can have our own user written functions. And whatever it is, the main applications are like for computation, for graphical representation, or for external interface. Okay. So we can write a program and externally interface it with our C programs, C++, Java programs, and we can whatever program we are writing, that can give us a 2D graphic representation or 3D graphic representation of the data. Color and lighting can be done, animation can be introduced, okay, and images can be worked up, and all data analysis, interpolations, all computer solutions for ordinary differential equation, partial differential equation, mathematical and statistical related activities can be. Okay, so these are the capabilities of MATLAB, and we go for specific toolboxes for specialized functions. Okay, so we have many number of toolboxes. So out of that, the prominent 15 toolboxes I'm listing here. So top MATLAB toolboxes are, first is your compiler tool. So before going to the toolbox, I'll just show the basic online simulator for MATLAB. 1 minute. So hope the screen is visible. Hello. Hello, ma'am, am I audible?
Yes, madam.
Yes, yes.
So MATLAB online, if we type, it will lead us to this mathworks.com website. So from that, we can go into MATLAB and Simulink. So we can open online MATLAB. So actually, initially, it will ask for sign in. Already I have signed in. Okay, already I have signed in. So if I open, otherwise, for education purpose, it is much free. So we can use our official mail ID to register. We'll get a password and verification code. So once we do that, we can go into online. Online MATLAB site, mathworks.com. Okay, MATLAB dot, here you can see mathworks.com. So already I have logged in and I have done some basic programming, and we have provisions for online training also. Online training, we have many courses available, like Coursera and other platforms. We have self-paced online courses, so we can choose whatever be the course. So here we can 2 hours or language can be changed. Okay, so these are the different courses, how to use MATLAB, how to use Simulink. So here it gives different categories. What are the courses available? So for AI and statistics, so these are the courses related to AI and statistics. And coming to this one, like we can filter the courses, and we different types of according to our need. Okay, and according to the application and workflow, we can choose any one of these. Based on the application, we can choose the course, or based on the simulation requirement, we can choose the course, or based on the basic introduction, data importing, data analysis, we can do the course. So these are different course categories which are available. So whatever it is, if you look at all are, this is all MATLAB means this gives introduction to core aspects of MATLAB, how to clean data, explore data. So all are self-exploring, self-paced courses. Okay, self-paced online courses where you can uh, develop your skills. Okay, so most of the basic science and engineering, they go for getting started with MATLAB graphics and programming. So under each course, if you look at, you will have this gives the what are the basic commands, vectors, matrices. So whatever we discussed now, so all can be taken up, or here itself, say for example, vectors and matrices. If you start inside the course itself, you will have a quiz. Okay, so quiz which will not as a real time means when we are working itself, or when we are going through the course itself, in between we will have quizzes. So these quizzes will help us to understand start module. So say for example, vectors and matrices, and start going for start module. So course is being launched. So everything is online, free. Only thing, with your academic mail ID, if you log in, you can easily get into and get access. Well, every user will be given a user ID like other Coursera and other platforms. So here you can, I think we need to have it taking a little time setting up the course. So not all toolboxes, as I told, in the next session, we'll be discussing in detail about the toolboxes, and then we'll go for um, visualization part. So not all toolboxes are in the online, online academy, MATLAB Academy, or in the online simulation. But we have many different basic essentials. Okay, so I think it's taking a bit longer time. Okay, so whatever it is, so online training you can go, and then if you open this, it will go to MATLAB online. So the course will open like this. What is an array? So you have task 1, task 2, everything here. Okay. So this is actually the MATLAB basic menu structure. So based
Screen is
on
not
that,
sharing.
this course.
Excuse me, madam. Your
Tell me, sir.
screen. Yes, ma'am. Your screen sharing stopped. Your screen de-shared. Madam, I have one question. Whether offline or desktop version is available free of cost?
No, sir. Offline is licensed version only.
Sorry, madam.
Offline is licensed version, so that cannot be. You have institutional license to the institution you can use. Otherwise, for minimal usage or for not only minimal, to moderate extent, we can go for some such implementation in online.
Okay. Yes. Thank
But
you.
offline MATLAB is not free. It is licensed version. We have to buy, and number of users are also there. Depending upon the number of users, the cost will vary.
Difference.
So this shows us. This is one simple example, like task 1. So it goes like we have to create a variable named x with the value 4. So that we have to do in this particular task. So here I am typing x equal to 4, and colon should be there at the end. Submit. Okay, so it goes like we can similarly we have, so this is correct. So it is like this learning process in MATLAB online is like with task mechanism. It's not of like video lecture like Swayam or Coursera or NPTEL videos. It is you will have the background, like basic information will be given, and then you will be asked to do a particular task. So it is like experimenting and learning. Okay, so this MATLAB on RAM is the basic course which I have chosen now to go for demo. Similarly, for higher level advanced programming also, we can go for courses are there, and for data analysis, data visualization, statistical analysis. So for research purpose, if we want to know about how to use MATLAB or how to go about different commands in MATLAB, so these online courses are very helpful for us. So here the learning is in terms of task. So again, create an array Y with 2 elements. Okay. So I have to go to task. So here I have to type task 2. Okay, this is task 2. Here you can notice this is task 2. Task 2 is you can create array with multiple elements using square bracket. So the description or the technical information will be given, and we will be asked to implement that and check as a task. Okay, so now I have to give here the variable name given is y. Y is equal to square bracket. What are the elements given? 4, 7, and 9. 7 space 9 and semicolon. So I have to submit here. So once I submit, correct. You get that your whatever code you have written is correct. In case if this code is wrong means, then I'll get it as incorrect. And I'll have option of changing it again and doing. So it is not like evaluated course, or some are evaluated course with certifications in MATLAB courses, but many of them are for self-learning and knowledge improvisation. So like this it will be, this is the course structure in MATLAB online courses. So this will help us to understand, even though we have offline license software, in order to use those commands which are available for one particular specific application, we can choose that particular course, and then we can learn how to go about the different built-in functions, how to identify the different built-in functions, how to use the different built-in functions in MATLAB. So this example is basic example what I have shown, MATLAB on RAM. So next we will go to the environment and basic commands. I think we'll have a short break and then we will take it up. Hello, ma'am, is it okay? Sir?
Yes, ma'am.
10 minutes or 15 minutes. How long is the break, sir, according to your this one?
Generally 10 to 15 minutes, not more than 15 minutes, but
Yes, yes. 10:40 we'll catch up by 12:50.
some by
About time is 10 minutes.
12:55.
12:55. Okay, sir. We'll continue. We'll stay online, sir. Hello, sir.
Hello. Yes,
Uh,
ma'am.
Can we continue, sir?
Yes, ma'am.
So this, hello. Okay. Sir,
Yes, ma'am.
continuing, I think all the participants have joined back. So this is one example of how online courses are being delivered by MATLAB, and with right from basic courses to higher level advanced courses we have. Few of the courses they are in fact okay, let me take the course. So this my courses. So my courses, if you look at, I have taken up this course. So once I come out of that particular course, I can finish, save, and certificate and progress. You can share the course details with your online portal and other things, and we can need to have a certificate and progress report. And apart from that, you have online training suite and documentation and support is also. So documentation, it gives full details about all the packages and everything available in MATLAB, including documentation for teaching and relevant to teaching and learning. How to implement or how to download, how to go about the different topics or how to go about the different toolboxes. So all these topics are given in documentation under teaching and learning category. So now we will move on to MATLAB online. Online portal, how it looks. So now we saw about the environment, basic functionalities, variables and other things, and basic visual plots. So those things we will see online in online portal. Open MATLAB online. So once I open MATLAB online, the entire MATLAB environment will be open online itself. It is this what I am showing now is not licensed downloaded software or installed software. It is online version. It will take time because the entire work environment, MATLAB work environment has been loaded. So now we can see this is the MATLAB environment for new file, opening file, save file. So these are the this is the directory which I have been working with. Since it is online, it is given as MATLAB drive. Okay. If it is offline for offline software, then here we will be having the entire location, path location of where we are keeping our files or current folder location will be shown. But since this is online, it is showing as MATLAB drive and all the files within that particular MATLAB, whatever I have worked with that particular online drive, that is shown here. And here we can see the files, whatever I have already worked. So here, like right from beginning, I have some basic files. Okay, get image. So if I press that, I'm getting. So this is a basic image, basic program where I have defined an image and I am showing it as an image. I have 256 rows, 256. Hope you can visualize this. 256 rows, 256 columns. And initially, I am defining an image with zeros. And then I am, so this is a script I have written in .m file. Okay, here we can, this is the file name with .m extension. Okay, so if I want to run this file, so in the environment, if we look at here, we have the run. So if I run, you can see this active file. So if I run this file, I should be getting an image if there is no bug. Okay, Say, for example, I am taking this particular example. So this is the create image. So here you can see the previous one, whatever I run, the output image is shown here. So in the output image, there are 256 rows, 256 columns, and I am keeping 0.5. For certain rows, I am keeping the pixel value as 0.5, and for certain other rows, I am keeping the pixel value as 1. Okay. So wherever it is 1, it is shown as the white color line, and wherever it is 0.5, it is shown as the gray color line. So we can notice from 100 to 105, it is 100 pixel 100 to 105, it is gray color 0.5, and from column 100 to 105, it is 1. Column 100 to 105, it is 1. Okay, so these are the basic commands to show the image as out. Okay, so this gives the visual output of the image representation. So here we have created an image. We created a simple image. Similarly, next we will go for, I close this window. I'm going for the next basic function where I am again choosing defining an image size of 2 by 256 and with some rounded off image. So when I run this, so I'll be getting, this is the random image. Okay, here we are defining with random to randomly distributing some values and then it is showing here. So similar to this, so this is how we operate in the MATLAB online environment. Okay, I'm just showing these examples. Say, for example, the next image, I'll close this image, or if I have this image, I'll get it as figure number 2. Okay, so this is the output. So next, third program, what I am running is third code, small code, what I am running is, I am reading an already available image in MATLAB library or environment. So pout.tif is a already existing image. So I'm reading that image and I am showing that image and I'm going for histogram equalization of the image in list of I. So whatever image I'm reading, I'm storing in variable I. So I'm going for histogram equalization of I. Okay, in this and his equalization. So when I run this, I'm getting the next window. So this is actually, there are two images. This one is original image. So that will be shown first. Okay, image is shown and image show I2. Okay, I2 is, I'm storing the histogram values into another image I2. So this is I2 and I is this one. Okay, so another one thing we need to know is like all commands will be ending in semicolon, but if we want to see the output in the command window or as a figure, then we should not put semicolon in that particular command statement. So these examples I'm just running to show you how the MATLAB online work environment will be there. Another one new feature what they have added now is here your Copilot, where you can generate and also generate some code whatever you want by asking the Copilot. That is generate AI also they have brought into the MATLAB online working environment. This is a recent addition. Previously, a year before it won't be there, but now they have included this option also so that a learner who is implementing can parallelly they can go for this generative AI will give comments or suggestions for better programming skills. Okay, or better changing of the program in case if any bug is there, we can immediately refer to and then we can change the bug accordingly. Okay, so these are some few examples I have done already. If we run this again, only one last example. So this is again an image. Show random image I have created, gray image. So these are different commands to write. Okay, so all these things can be understood by going for. Here we have home. We have different help is here. So whenever we are stuck with any command or anything, we can go for help. Under help, we have documentation examples. Okay, community is actually MATLAB online community is there, matlabcenter.com. So where people post their codes and other things. So from that, I'll show you online also MATLAB community. So if I press that, it goes to matlabcenter.com, matlab.matlabcenter.com. So this is the community portal where different people, they have posted their codes, whatever, conversion from Fahrenheit to Celsius. These are simple codes which may be helpful. And we can search inside the portal also. Actually, this icon, if I go here, I can search inside the portal. Visualization. Visualization code. So if I search, I'll get documents or example to that particular code. So this is the name. So these are few examples of visualization codes. Matrix visualization as an image, how to visualize matrix. These are examples which this is like a forum. Okay, this is like a community forum for MATLAB users where they can share codes and other things. Okay, so when other documentation, so this is the online work environment. Documentation, if we want, if you press documentation, it will go to documentation. The documentation of entire MATLAB, entire like what is MATLAB, how to use Copilot along with MATLAB commands, Simulink, okay, how to use Simulink and workflows, application-wise contents and workflow-wise contents are also given under documentation. Okay, so here using MATLAB, using Simulink, and all these are so individually. If you go inside Simulink, MATLAB Simulink is actually Simulink is the uh, simulation software related to MATLAB. It is for multi-domain simulation. Multi-domain means all types of research what can be carried out, like Python circuit analysis, neural network. So you can design any model and then you can test that model, implement that model, simulate. So these are the things. What are the fundamental components available for modeling? So what are the design models for dynamic system? How to simulate and project management. So simulation techniques, simulation supported software. So all these are given. So we can implement with hardware also. Simulink can be implemented along with hardware also. So we can model and test it with a particular third-party hardware also. Okay, so all these hardware testing capability, everything for everything, documentation is available. Okay, for example, if I go for one small application-wise, code will also be available for certain cases. Say, for example, decision logic. Decision logic means here are few examples, featured examples are there. And if I battery management system, and for example, I'm clicking one example. So here you can see the entire description, and in some cases, code will also be available here, like copy the command. Okay, so actually this entire code is given as a what if you M file. Okay, open example M file. I can either open in MATLAB and check the entire simulation, understanding of this entire simulation, or I can copy the command and run in my MATLAB environment separately also. Okay, for example, so this is a battery management system. Okay, so this battery management system, if I want to know about battery management system, if I want to learn about how to simulate it, how to create a model, how to simulate a model, how to test that particular model, everything, every documentation will be available here, along with the results, how to, what will be the result and how the result can be visualized and validated and how the result can be interpreted. Everything we can understand from this documentation. And say, for example, if I want to run this and check, I have to click this open in MATLAB online. So once I click this in open in MATLAB online, my command continuing existing way. Already I have been showing examples. So those windows are So in the MATLAB online work space or workbook environment, the example is getting open. Whatever example documentation we saw there, the code related to that modeling simulation, the entire code opens here. So this is the command window. Minute it has to load. So the entire battery management. .mlx file open. This has to, so once this is open, I'll show another one example. .mlx file. So I think I got disconnected, so I'll share again. I'll show you another example. Okay, I'm having some connectivity issue. So if I run this, so this shows another example. Next, I will where color image is being converted into grayscale image, the black and white, not black and white image, grayscale image. So this is how we can work with images and that MLX file. One thing. So this example I have from the documentation I had opened in an online editor. Okay, change folder. It's running. This is actually an example showing uh, high resolution image processing. Okay. Okay, this is how This example actually it takes time to compile. We'll complete the other portions and then come back. So now these are the basic MATLAB work environment online, and then we discussed about how to go to online courses need search bar MATLABcentral.com. We will. The next coming the top toolboxes. Can you see my screen? Hello.
Your voice is break, madam.
Sir, now is it okay, sir? Now is it audible?
Yes, madam. Yes.
Yes.
Yes, madam.
Yeah, okay. So there are different toolboxes. Compiler toolbox. Compiler toolbox is mainly when you need to show demo or when MATLAB is not installed, then you can compile it into a executable file and then or as a web app and then show it for presentation and other things. So that is the purpose of compiler toolbox. And statistics and machine learning toolbox. As we know, most of the research, whatever we do in many of the domains, they are requiring statistical analysis and other analysis like machine learning based analysis. So all these can be done with statistical and machine learning toolbox. So we have built in algorithms for classification, regression, modeling, and clustering. And different tools are also available for feature selection, dimensionality reduction, and hypothesis testing also. Statistical function for hypothesis testing, probability, distribution, fitting. All these capabilities are there. So researchers in the field of computer science, data analytics, bioinformatics, they will be in need of this particular toolbox to a large extent. They will be the prominent users. Next is your Simulink. As the name indicates, it is the simulation toolbox. It is a well-renowned toolbox for engineering students for multi-domain simulation and model-based design. So it is a designing and simulation control mechanism where you can the parameters, dynamically model the system parameters, and then check their performance. And in case, based on the output performance, we can modify the parameters also. Next is image processing toolbox. Image processing toolbox is mainly used by biomedical and biotechnology and people related to computer vision also. So image enhancement and noise reduction is one of the few major operations which is being carried out by many researchers. And object detection, segmentation, and morphological operations are specific for medical image processing and other image. So medical imaging, not only medical imaging, remote sense images, all these are being handled by image processing toolbox. Next is deep learning toolbox. So in deep learning toolbox, there are built-in deep learning models like CNN, RNN, and generative adversarial neural networks, DANs, and these models can be integrated with TensorFlow and PyTorch. So in other software, all these are not available as pre-built algorithms. We have to run the code and copy paste the code and run. But here in MATLAB, with one keyword, we can acquire the entire model and functionality of these neural network models, deep learning models. And visualization tool is also possible for these AI-based toolbox application. Okay, and for students working on AI-based projects, this toolbox is a very vital toolbox for their implementation. Next, apart from that, we have control system toolbox, mainly for system design, mechanical and electrical system design. Optimization toolbox, it is for mathematical optimization, solving linear, non-linear mathematical operations are optimizing coming will be more using this optimization toolbox. Next is signal processing toolbox. Signal processing toolbox, whatever model is created. So this again is a different domain where many engineering disciplines, they are biomedical or biomedical signal processing is also a domain. So for them, again, this toolbox is highly used. Financial toolbox also. So MATLAB not only pertains to engineering and science, maths or science, it also pertains to financial data. You can go for time series analysis, risk assessment, derivative pricing, and portfolio optimization. All these finance-related toolbox which are meant for finance, economics, and business analytics. Applications are also available in MATLAB. Next is bioinformatics toolbox. So bioinformatics is for the students of life science and biotechnology. So where analyzing biological sequence of data can be done, visualizing molecular structures can be done, and conducting phylogenetic analysis can also be done. So for researchers in domains of genomics, genomics, and computational biology, this particular toolbox will be highly useful. Next is parallel computing toolbox. The parallel computing toolbox enables distribution computing over multiple GPUs, multiple cores or GPUs. So large scale simulations are also possible, and this is it will speed up the iterative algorithm. As we know, MATLAB, it is computationally expensive, or it means that it requires a large amount of bandwidth and data capability. Computational overhead is very high. So this can be extended to other multiple cores, and then computation can be done at a faster time period also. Okay, or it can be integrated with the GPUs to speed up the algorithm. So that is the purpose of this parallel computing toolbox. So higher and advanced implementations where data analysis and visualization is a major criteria or major task, then parallel computing toolbox can be used. And apart from that, robotics system toolbox. So all these toolbox, related documentation, related example codes, everything is available online. And computer vision toolbox. Computer vision toolbox for video analysis, 3D reconstruction, entire object tracking, motion analysis. So these are applications of research areas where computer vision toolbox is used. And not only these technical and scientific usage, it is used for grading also, for learning experience also, like our normal LMS. Okay, so here we can create and share MATLAB interactive assignments. So automatically these assignments can be graded. So the students, like our LMS Google Classroom or Moodle or Teams, or where we have LMS to create assignments and grade the assignments and track the progress and performance. So all these things can be done in MATLAB also. Not only for scientific application, it is also for financial and educational purpose also. So we can track the progress and performance of the students, and this will lead to active learning and self-study in a collaborative frame. Next is the communication toolbox, which is for signal communication. This is again a specific technical tool. So these are the prominent toolboxes which are being used. So as we saw earlier, we saw a MATLAB environment in online, but this screen shows in offline. Okay, in the offline mode, when you haven't installed a MATLAB software, this will be the MATLAB work environment. You have the current directory, you have the workspace. This is the editor, MATLAB editor, where files will be opened here. Okay, and this is the command window. Command window will appear here, and you have this command history also. I think it's shown below this particular thing. So you have a command history. So previously, whatever commands were run, those will be shown in the command history. So this only I had gone through. I showed you all the basic documentation and how to open in MATLAB online and Simulink. So now we will move into Simulink specifically. So the third module is MATLAB Simulink. The MATLAB Simulink. The MATLAB Simulink, we concentrate mostly on visual. Since our topic is pertaining to visualization, we will analysis and visualization. We will go further. Simulink in proper detail. So it is the tool for computing, technical computing and simulation, and it is widely used for engineering and science disciplines. Okay, so we can create graphical model-based simulation and other things. So MATLAB Simulink, how to start Simulink is go to in the MATLAB window. This is the workspace, current directory, command history, command window. We have the icon here. This is the icon. We have to click here to start Simulink. Okay, and we can see the current directory. So in the current directory, we should have the current directory. Here we can see the current directory. In the current directory, whatever files we are working, those files will be shown here. Okay. So current directory is shown, and this is the icon to start Simulink, and all our working files will be shown in all files category, current directory and workspace we can see. So next, coming to the Simulink library browser. So here, what components, how we are going to model. We'll show one example for electric circuit, how it is being modeled and tested, and how to visualize the output and other things. So now, this is the Simulink library browser. So here, file, new, if you go for model, this particular window will open. Okay, so this browser actually gives access to different standard blocks that are used in a particular model, and models that can be constructed from the Simulink library. So once you go to this new model, then this particular window will open. Okay. So after opening this window, actually now our aim is to any physics or related people will understand this more in detail. Like say for example, I have a circuit which has to be simulated. So the equation giving the model of the circuit is IR is, so this is the output variable, this is the input variable, and this is the some amount of gain variable. Okay, so in simple languages we are speaking. So these three have to be modeled in the Simulink environment, and then we have to test the output. Okay, so this input will be a sine wave. As we know, this VAC means it is going to be a sine wave. So from the library, we have to choose sine wave. Okay, and so here what happens, and from the library for this particular variable, we have to choose the gain block from the mathematical operations in the Simulink library. And for this output, we have to choose an output scope variable, that is scope in the sense display output. Okay. So all these three are shown here. Input is sine wave. So drag and drop, we have to drag and drop sine wave block from source in the Simulink library. So library we saw earlier here. So here you have the library, Simulink library. From this, if you scroll down, you will get sine wave block. Okay, so that has to be dragged and dropped here. And similarly, gain block has to be dragged and dropped here. And this is output scope. Scope means that visual, what you say, CRO or whatever, what we use in physical lab. Okay. So this is after placing all these components, we have to connect them and specify the gain as 1 by 10, and whatever the gain here given is 1 by 10 according to this resistor value. Okay, 1 by R means 1 by 10. 1 by 10 is given as a gain factor, and input and output are specified. Next, what we do is, after training the circuit or after implementing the model, we have to start the simulation by pressing this run sim. Okay, click here to start the simulation, and time period of simulation can be varied here. So total simulation time can be changed here, and then we can see the output here, okay, in the scope. So we are giving a sinusoidal input, this output. So once you double click the scope, we'll be able to see the scope output here. And so this is how you simulate and you check the output in the simulation. These are other additional characteristics of simulating plots. They have 0 or 1 or more inputs. Not only one input, you can have more than one input. And input and output, everything is considered as signals. Okay, so this one other software like PSpice, they are circuit oriented, but here we have other variables also. All types of variables can be simulated and checked. So another one example is, already you have two different files, pv1.model and find mpc.yam file. So all these are in current folder. The current folder, you should have those files. So one way is like dragging and dropping and showing, simulating and seeing the output. Another way of simulation is having the model files written. MDL is nothing but model file, and this is the .m file, main file. Okay, so here you can see model file and MATLAB file. M file means MATLAB file. So once you run these two, okay, once you click on these two and run them, then this example is actually PV, photovoltaic cell simulation. So photovoltaic cell actually it is implemented with this. So once you run, the schematic will be popping up, and then you will get the output simulation output level. Okay, so this is for the variable PVP, and this is output power variable, and this is output current variable. Okay. So this is an example of how we are simulating. So in order to simulate, we have to double click and then run the particular code. And in the command window, we'll be able to see the numerical output values. So graphical output values will be shown in the figure window, and in the command window, numerical output values will be shown. So this is how we go for simulate. Class H4 online in mathworks.com. Simulate. We have model-based design. We have different documentation, and so this is documentation. Similarly, you have examples and what are the functions available, everything. Documentation, examples are here. Simulink examples and functions are also available. Okay, so these can be utilized for better understanding of the concepts. So next, now we will go into few details about online. I'll run and show few examples of plots. Okay, visualization. This is the online. One minute. We'll run through few examples showing plots. Okay. Simple plot. So first is a simple basic 2D plot. So the command is plot x comma y. So Simulink is over. Now we are coming to normal plot and other visualization graphs. Let me open MATLAB online. Now I want to add a new file. So I'll go either here, I can go create new script. Like this I can go, or from here I can choose one particular plus, this plus icon I have to use. Okay, so that I'll get an editor window. Now I have whatever from this Word document, I am going to run a very simple code for plotting. Okay. So this plot I have code I have done here. So x variables running from 0 to 10 with an increment of 0.01. Okay, x is a variable having values from 0 to 10. That is 0, 0.1, 0.2, 0.3, 0.4. It goes on till 10. And y is nothing but sine of x. So now I have to plot this. So this is a very simple plot, sinusoidal plot. After running, when I run this, so this is the sine wave I have created. So this code simple code is a 2D plot. So it's a 2D plot with x-axis and y-axis. So in this, so next we will run another one code. So in order to, if you want to customize your plot, okay, you can add X label, Y label. You can add the title as my plot, X label, Y label, all these things. Like you will get the, so here you get options like, okay, data tips, customizing. Here you will have customizing and other options to edit the plot variables. So from using these, you can edit the plot variables, and then you can save it also. You can save and or copy paste it. Next, I will show a 3D plot. 3D plot with mesh. So again, I have to go for another one. Another one, editor window. So this we call it as editor window. This is the command window. What we have down here is the command window. This is the editor window. Editor window will be used for creating .m files and .mdl files. Okay. So this editor window, I have copy pasted the code for creating a 3D mesh grid like figure. So this is the grid visualization. Okay, you can see the hat-like structure in 3-dimensional. So this is a 3-dimensional image where we have options of labeling them, and then we can label and give title everything. And in that particular grid-like structure, wherever you place, you can see the values of x, y, and z coordinates. So this is how a mesh grid is the command or function to create such a visualization plot. Okay. So this is done for square root function of sine of the square root function, and this this stuff is nothing but mesh grid actually creates the grid-like structure, and surf is nothing but the surface plot. SURF stand for the surface plot. And apart from that, we have specialized plots. For bar chart, it is bar, scatter plot. Histogram, we have already seen one example will be there, and polar plot also is possible. Okay. We see other examples. So these are basic operations what we have already seen. All are related to image. So image arithmetic operations, we saw this in that B lab. Okay. Similar operation can be done in MATLAB also, image arithmetic operation. So one example I'll show here. I have to create a new M file. Okay, so here two different images, rice.png and cameraman, two different images are taken, and I am using the command im_add to add those two images. So you can see actually there are two different images. One is cameraman image and another one is rice image. So once I give add, it is giving the output image like this. Okay. So this is from here I can visualize the pixel values. So at each and every pixel location, actually we can get the pixel value, pixel intensity value. Pixel value means that it is the intensity value. So this is one example. Similarly, image subtraction can be done, and these are small examples. Okay, and I'll show you one. Linear combination of images. So many different small examples are there. So we can 3D plot. So this is a very simple code where I'm giving a peak of at 25 and I'm giving a mesh plot. Okay, this is a normal mesh plot. This can be rotated and we can use this to rotate the plot and see visual. So we can like this. So different angles if we see what is. So this particular icon should be used. Okay, 3D, how I can see the plot. So this is X, Y, Z. So in each specific angle, I can keep, then I can take, I can save them. Okay, save it as a file. So this is one example of how 3D visualization can be done. So whatever is your data, you can run the data and take it as a mesh plot, and then in 3D we can visualize all the data points. And one more. So this example actually is taken from it is taken from documentation. I'll take some other virtualization code. So AI and statistics toolbox based applications are shown here. So now you can, example, you can, the topics which are available are machine learning, deep learning, reinforcement learning, and AI modeling. If we look at, these are the different AI modeling and simulation possible. That is like training classification models, and then train regression models. So these are available in the statistics and machine learning toolbox. And this particular one, build networks with the deep network designing, that is available in deep learning toolbox. So these are different toolboxes and their usages. So here are some examples. Here is one example. We'll check this semantic segmentation. You can copy this command and then place it in. We can get the command, and then here you can see the entire code and the related documentation. Okay, so each and every application will have similar documentation for that, related code for that, and the corresponding output will also be available. Okay. So this is how MATLAB can be utilized for uh, moderate or higher level research analysis, and we can have different types of plots, visualization, and everything. One more example I'll show you with this is for data analysis. whatever you download from the documentation, say for example, it will download as a zip file. So here I have taken one example from the documentation only for data analysis. So this data analysis will be having inbuilt data analysis part 1. It gives all the required files. Okay, it will give the YAM file, the data table, the data array, every data will be available, and we will have an YAM file also. So this YAM file you have to run, you have to open in text and then copy paste it and put it in MATLAB and run. So once you run that, you will be able to understand or visualize the entire mechanism or entire working in your desktop. Okay, not only in MATLAB, in our desktop you can visualize. So next, I'll cover a few topics related to image processing toolbox. So we saw one example with image processing. This example I showed you online itself. And this example also with random generation, I have shown you always. So this example, it shows. So this example, it shows the image as, say for example, a binary image. Binary image is nothing but it is in terms of ones and zeros. And intensity image is nothing but it is in terms of some numerical values, not as 1 or 0. And RGB image means it will have red, blue, and green values. Okay, so it will have three values. So it will have three values: blue, green, and red RGB values. So each and every pixel value will have one intensity. So that is how image is represented is in the form of digital image. If you look at discrete image levels are there. Okay, so discrete image levels, we can store the bits at various levels, values from N to K. Okay, so different types of how image is being processed is primitive operations can be done. Primitive operations is nothing but sharpening, adding, and basic arithmetic operations can be done. Segmentation can be done. Segmentation is object recognition, classification, and processing. And uh, attributes, that is making sensation or making decision, higher level processing can be done. So that is in terms of object recognition, object analysis, okay, related to computer vision mechanics. So the key stages in any digital image processing is, first is image acquisition. We acquire the image, then we go for enhancement of the image, then we go for restoration of the image, and some morphological operations can be done. And then we go for segmentation of the image. For segmentation, we go for histogram filtering and other methods. And then object recognition can be done. And representation, how we represent the image in terms of contours and other points can be done. Okay. So finally, we store the image and then we process the image in color format. Okay. So these are connectivity issues. This is the main thing. These many image operations are possible. All these are very simple operations, and one command in MATLAB will do all these operations at a time. Segmentation. We have different types of filtering, image filters, segmentation mechanism is there, contouring operations are there. Okay, so all these things can be done in MATLAB. The same things we can do in Python and other coding also, but we have to write the code. But in MATLAB, it is one command because in MATLAB all are inbuilt functions. Okay. So this is related to the online MATLAB and related Simulink. So since the topic being AI for visualization and data analysis, I thought of taking up MATLAB it's because MATLAB everybody will not have access to licensed version, but online MATLAB is of very high use for any researcher. Okay, so only thing is you need to log in with your mail ID. You get validation to your mail ID, and then once you validate and verify your mail, then you can go for any documentation examples, functions. Say for example, functions in here. functions in this particular computer vision. The computer vision category under functions, this is an example. So different functions under computer vision toolbox or computer vision related functions will be shown here. It is still loading. And blocks. So these we can explore into. The one main thing is for teaching and learning, we can use the online MATLAB courses which are available. The main page, if you look at, you will have the main page. Hello, sir. Am I audible?
Yes, madam. Now,
Yes. Yes. So if there are any questions, I can take it up now.
I have one question.
Then we have done 4 different modules. First one is related to online virtual labs and stations that are available both in various government of India. Next, we discuss about MATLAB online and what are the resources available, how MATLAB can be efficiently used for research purposes under science and engineering domains. Not only science and engineering, for education purpose also MATLAB grader toolbox is there. And for finance and accounting purpose also toolboxes are there. So on a whole, it can be utilized. There are again certified courses and self-paced courses available online. So if there are any questions, I can take it up.
Madam, I have one question, not
Ah,
academic
yes.
one, but non-academic
Yes,
one. Madam, you have shown with MATLAB we can add image and subtract image. Is there any
yes.
code or tool, or in MATLAB can we remove background and can have a single entity in the picture shown there? We come across like signature we generally put in Word file, and the image that we have taken come up with the background, and that
Yes,
look
sir.
ugly. So can somehow we can just extract image part there, and that will remain transparent on the paper. Can we do that? Or even with the low
Actually, in MATLAB, we don't have a single command. We have to write a bit of code for that.
okay.
Like,
Can we do that with the
But it
MATLAB?
is available online MATLAB Central. If you look at it, is available, sir. Like
Yes, and
BG
any
remover.
other? Yes, ma'am. And any other tool other than MATLAB?
But online we have many tools like BG remover.
BG
Free softwares are available. BG remover. Just put the keyword BG remover, background remover.
Okay.
There are many free portals. You have to upload the file and then select like our PDF online file or PDF or something, converts and things. We can download the image. There are many portals. BG remover.
Yes, ma'am. I'm trying.
MATLAB also you have, but inbuilt it is not an inbuilt command. In MATLAB Center you have a bit of code, small bit of code, which you copy and run in your MATLAB environment. If you want to be more secure, if you don't want your image to be uploaded on free portals, then you can go for this MATLAB Central File Exchange, that community portal. What I showed, it is available there.
Okay. Yes. Thank you, ma'am. Thank you.
Okay.
If anyone know any doubts or questions, can I propose vote of thanks?
No doubt, sir. No doubt.
Yes, sir, you can propose vote of thanks.
Okay, thank you very much. Good afternoon, all of you. Everyone, on the behalf of organizing committee, it's my honor to extend our sincere thanks to our today's resource person, Dr. Anita, Christaline, John Victor, Madam. We are deeply grateful to our chief guest, Dr. Anita Christaline John Victor, for her thought-provoking address on virtual labs and simulation. Madam, your detailed explanation of virtual labs, MATLAB online, MATLAB Simulink, theoretically and practically. Top toolboxes in MATLAB, image processing through histogram, how MATLAB is useful for research data analysis, how MATLAB gives us self-paced online courses was truly illuminating. Your guidance today has truly inspired us. We are grateful for your dedication and effort. Thank you on behalf of everyone present here. I also gives my sincere thanks to our director, Professor DJ Mahajan, and also gives thanks to our course coordinator, uh, Namrata Mehendra Madam. Once again, thank you very much, Dr. Anita Madam. And with the permission of course coordinator and director, I declare that today's morning session is now over. Thank you very much, Madam.
Thank you, sir.
Thank you, sir.
Thank you all.
Thank you all.